So this is the guitar that I am basing the 3D printed guitar off of. This is an LTD Aero 1000. Starting out, I rarely use my neck pickup in my other guitars, and I really need that real estate for some other stuff, so I went with an EMG 81 in the bridge. After doing my research and seeing all the positive response for Geiger hardware, I was on board and it really just didn't disappoint. And same goes for the tuners. They're super hefty and I cannot wait to use them. Unfortunately, they're not going to work for this design for a couple reasons, but they're definitely going in my next build. All right, let's take a look at the 3D model. Nothing was pre-built here. I started with the same blank screen that you're staring at right now. For the few people that do actually pay attention to this stuff, I'm working in Fusion 360, which is basically just a CAD program or a modeling program. We're looking at the core right now, and this is basically just the center section that kind of brings everything together with the pickup, the bridge, and the neck. The tunematic bridge goes right here, and you'll notice that it's a little bit recessed. Typically, it's going to require that the neck gets just slanted a little bit to account for the height of the bridge. I didn't want that. I wanted the best of both worlds. I wanted a straight neck and I wanted a tunematic bridge. Here you've got the pickup cavity. Of course, there's the big square-shaped elephant in the room, and I'll get to that. On the back side here, you've got the area where the strings route, and there's going to be ferrules on both sides, the top and the bottom. The core might be the heart of the guitar, but the underside of the body is what makes it all come together and be a usable instrument. This is the underside of the body. It's the connective tissue where everything kind of connects together. First up, we got the spot for the strap here. I've got a spot for aluminum plates on both sides of this. The guitar jack right here, power switch, and a USB input. Interesting. Concerning. This is a plate that's going to hold the volume knob. I actually don't like tone knobs on guitars, at least not for the metal. So let's go ahead and hide that. And you can see there is just a cavity that's going to be accessible from the other side, just like the back of any normal guitar. Of course, my 3D printers are only so big, so that's why it's split up into 3 sections here. And I can make it look like one piece when I'm finishing it. But really, aside from just figuring out how all these pieces are just going to solidly connect together, these were actually one of the easier parts to print. From here on, there's a lot of overlap between the structural side of things and the aesthetic or design. Have you ever heard of H.R. Geiger? This guy is an evil genius, and he's where I got my inspiration loosely for the design of this guitar. If you're not familiar with him, maybe you'll be familiar with some of his work. The xenomorphs in the movie Alien. He does all sorts of, well, he did, rest in peace, all sorts of artwork and sculptures in that biomechanical style. I don't know, I've always been infatuated with that style. I mean, my tattoos are all in that same vein. Whether or not I'm going to be actually successful, that's another question, but I'm going to give it the good old college try. To support that design, I need to have something that's going to sell it. So the goal is to have programmable RGB LEDs worked into the design of the front of the body, as well as all the way up the neck and even on the headstock. And I thought, you know what, it might be cool if I was able to tune my guitar with motors. That was a fleeting thought. I really didn't think it was even something that would be possible because of how small the motors would need to be. And then I saw this video. It's a college project, and crude as it may be, he had the idea first, so I gotta give him props for that. Now, to be fair, a company named Tronical came up with this concept and then licensed them out to Gibson for a bit. I don't know why I think that I can do better, but I don't care. I'm gonna try it anyway. Okay, back to the model. Since I need to power all of these things, there's gonna be a battery pack in that square center of the core that we saw earlier. If you're an eagle-eyed viewer, you probably noticed that there is no neck on this guitar. It is in another file since it is such a complex design. A typical neck is either gonna be one big slab of wood or it's gonna have some kind of scarf joint for the main length of the neck and the headstock. Can't really do a scarf joint on a 3D printed neck because you need a little more support in between the headstock and the neck length. So to make it as stable as possible, the headstock joins into the neck with this sort of Lego type connection point, and then I use these big old M5 bolts that go right through the headstock and into the neck about this far or so. If that doesn't hold it, honestly, nothing will. So the center section has an area for a truss rod, obviously. From there, we've got a spot for carbon fiber strips, and this is gonna help with the rigidity of the neck. On the far sides, we have channels for wires. Believe it or not, printing this section was difficult. I know, shocker. This thing takes like between a day to 3 days to print, depending on how I print it. So after trying this for like 2 weeks, I figured out that if I just printed it straight up and down, centered on the build plate, but angled slightly, I was able to get this entire piece on one print. Here's the fretboard. I have a feeling that people are gonna be really divided about this depending on how much of a purist they are. It's different. This is trying to channel that H.R. Geiger-esque kind of alien look. So you've got a bunch of repeating patterns up the entire length of the fretboard, and all of these holes you see here are where the LEDs are gonna go. Flipping it upside down, you can see the areas where the LEDs are recessed into the fretboard. I bought an ABS nut and it was fine, but it felt like it just really wasn't designed for this kind of guitar. So I designed one and I dug out an old roll of ABS that I had lying around. I printed it and I'm happy to report that this is the one and only thing on the guitar that I only had to print twice. Functionally, it seems perfect so far, and if it does fail at any point, I could just print another one. So it's not that big of a deal. By far, my favorite part of this design is the headstock. The idea is that LEDs are going to be running up the length of the fretboard through these little channels here and into this little light bar, which has sections here that will be emitting light and pushing light up through these tubes that are sort of emulating a fiber optic type of illusion. And I think as I turn the model, you can really start to see the dimension come to life. There you go. Oh, that is so cool. I know that the monotone look isn't really doing it any justice, but it's pretty neat. Okay, I'm getting antsy. Let's check this out in the real world. So let's do some arts and crafts here. I'm going to assemble this so you've got the top of the back. Fin 1, let's not knock these over. I've already done that once today. Fin 2, and then we have the core. This core is about 50% infill. You cannot bend this in any way, shape, or form. This slides right into this cavity here. You have the start of a 3D printed guitar that looks something like this, completely hollow representation that I printed just to make sure that I knew what I was getting into. Now we get into the fun stuff, and this is where it completely does a 180 from what a typical guitar build usually looks like. Where's the fun stuff? Where'd it go? All right, it's over here. Now this probably doesn't look anything like the type of components that you would use in a guitar. 18650 lithium batteries. These are going in here. USB connector, which is going to go here. Power switch, and this is gonna go right in here. You've got a relay or two that's gonna go in here, voltage converters, a rotary encoder, some buttons and a screen, a microcontroller, a ton of various LEDs, programmable and otherwise. Probably gonna need a fan because of all these electronics. These are DC motors, which are geared for more torque. I did some quick tests and they are more than powerful enough to handle tuning. There's a lot of steps before I can get to that. So right now, I need to focus on building the best guitar I can and slowly integrating this stuff as I get to the point where it makes sense to bring that in. All right, let's talk about this neck. This is 100% infill, so there's no space in between all of the layers. That means that it can't crush over time. Of course, it can bend because it's plastic. Only so much you can do about that, but you can reinforce it. Taking a look at this one that is a little closer to being done, if I hold down the truss rod in there, you can see it's a lot more rigid already. Now there's still a little bit of flex, but again, keep in mind there's no fretboard on there, there's no carbon fiber. I'm fairly confident that I'm gonna get a neck that can actually hold its shape once you string it up. But you know what, that remains to be seen, and if it doesn't work, I can just go back to this and do something fun with it. Let's move over to the fretboard. The many versions of the fretboard just to get to a state where it has frets on it. Started with this, which is just a blank that I mocked up really quick. This worked okay. Problem that I have is that it's too tall for the printer, so I had to find the right orientation. I figured out that if I were to print this on its side, I was able to get it to print perfectly with the minimal amount of supports necessary. So what I had to do was split it in half. They just go together like that, glue it down, and it is good to go, and it works perfectly. So obviously this doesn't look like a normal fretboard, and that's because I wanted to have something that honestly, I just wanted it to look cool. I created repeating patterns all the way down the fretboard. Every single fret has 2 LEDs, one on each side. Now the inlays were a little contentious. I wanted to do 3D printed inlays and then had a little layer over top of it that was black. You wouldn't even be able to see the inlay until it lit up. That was one of those better in theory ideas because as soon as I tried it, well, look, noodled around with a few other ideas and eventually landed on resin. This stuff is simultaneously the easiest and hardest stuff to work with on the planet. What I found was that as long as I had the ratios right and I waited the right amount of time before starting the process, it was fine until it wasn't, because you see, resin wants to do what resin wants to do when it's got 45 minutes plus to cure. If that area is not absolutely watertight, that resin will find every little nook and cranny to crawl out of. What really got me was the curvature of the fretboard, because it's not flat, so when you pour that resin in, it looks fine for a while, but over the course of a few minutes, it starts to want to sag into one direction. So you have to have it almost bubbling up and out to account for that extra space, and obviously that adds risk for it starting to run. I shouldn't be complaining. It actually turned out great, and I'm super happy with it, but there was a lot of work involved to get to that point. And then after that, you've got all of the post-processing that needs to happen. Speaking of post-processing, I've decided to not really go into that side of the process too much right now, mostly because there's so much of it required that you can just pretty much assume that every single step that I take, there needs to be post-processing done in some way, shape, or form. Once I get to the finishing stage, I'm sure I'll have a lot more to say about it, but right now just know that there's a ton of sanding, a ton of ripping off supports for 3D prints, lots of stuff to make my hands hurt. As far as these LEDs go, these mount directly on the back of the fretboard. Wires will be run across the entire length. They'll get super glued in, and then I will cover all of this with a shielding that has a thin film so it doesn't actually come in contact with the edges of any of those wires. Shielding came from shielded network cable. I basically just ripped the wiring out of this, and that left me with a bunch of wires that had this aluminum shielding on it. So I pull the wiring out of there. It has a thin coating that is non-conductive. It's just wide enough to cover the entire back of the LEDs. I also shouldn't glaze over the fret markers, because the top fret markers all have these tiny little SMD LEDs, which are basically LED lights that are meant to be mounted on a circuit board. But yeah, that caused some heartache too. During the process of wiring and soldering in everything, the heat had warped the fretboard. So I had this almost complete fretboard that I had to completely redo. I tried hard to get it to work first. I used a heat gun and clamped it with aluminum and just tried to very slowly work it back in, but it started to introduce additional weak points and flaws the more I did that. So at some point, I just finally had to call it and start over again. Now, because this is a prototyping process and I didn't want to glue everything down, I wanted a way to be able to screw on the fretboard and then take it off if needed. On every fret marker, instead of having dots, I added little screw holes that I can then screw into the final version of the neck. So the neck also had to be printed with screw holes, and I could use heat set inserts or something like that, but I wanted something that was absolutely going nowhere. And to me, there's no problem at all with having holes on the back of the neck as long as they are well rounded off and don't interfere with playing. Plus, the added screws definitely gives it a bit more of an industrial aesthetic, which I just think is the coolest thing ever. Clearly. The fret wire that I bought is just 2.7 millimeter jumbo fret. They work great. They seem to be pretty high quality. They're stainless steel. What I didn't anticipate was that the frets were just too straight. I 3D printed a little jig that I could use to properly bend them to the most common type of radius. Just take that jig, put it on the table, then put a fret on there, and then just take a hammer and just very carefully and slowly hammer it into a better radius. Once I was done with that, I was able to take that same jig, attach it to a clamp, and then use this with the clamp to press the fret wire into the fretboard with even pressure along the whole thing so it slides in perfectly and you get a nice even surface across all of the frets on the fretboard. And of course I use super glue to make sure that once those things go in, they're not coming back out. And with all of that done, I can start to move my focus a little bit more to the electronics to make sure that everything is functional, because even though I have micro tested a lot of these little features that I've been adding, I haven't really collectively brought it all together yet, which is where we are headed on the next episode. So that is probably a good place to stop for today. I know that you hear it all the time, but it's important. If you are interested in this build and you want to see more, click the subscribe button. If you have thoughts, opinions, gripes, drop them in the comments. Let's talk shop. Until the next video, if you want to connect with me, you can find me on most of the socials at Metalhead Maker. There's a couple here and there that have to be at Metalhead Maker Chat. So if you'll excuse me, I need to go play with some electronics and get lead poisoning. Bye.